Could life begin in oil? Organic chemist Paul Brocker is leading a research team on that out-of-this-world concept. And what would life look like on other planets or Earth if it began that way? In the Department of Chemistry at St. Louis University, Brocker's team is off to a good start. The National Science Foundation is giving the lab a near $600,000 grant to investigate the idea. The origin of life is considered one of the most compelling mysteries.
We don't know what it's going to be useful for, but why wouldn't you want to have an answer for what life is? And once you do, you just got to think that that's got to be useful for something. It's going to be a big deal.
So the NSF partnered with NASA to encourage research, inviting scientists to explore new ideas. The SLEW team is one of 5 groups of chemists and biologists across the country involved in the project. Their proposals were generated at what's called an ideas lab. They were sequestered and told to develop out-of-the-box ideas about the origin of life.
NASA and NSF wanted to invite people that had backgrounds in all sorts of areas that were relevant to the problem. Our problem was figuring out new ideas for how life would have originated on Earth.
On Earth, water makes life as we know it possible. But some celestial bodies are covered with liquid oils. Saturn's moon, Titan, became the group's inspiration.
It's covered in lakes and oceans of liquid methane with some ethane in it. And so those environments, you have a liquid that's present that's able to serve as a solvent. But the molecules that are found in an ocean or lake that is composed of that, they're going to be very different. So what our idea revolved around was figuring out how the rules of the game change.
Were life to develop on oily worlds, Brocker says the biochemistry of these organisms would have to be different.
We know a great deal about how life functions in water and what DNA and RNA and proteins are able to do. When you change to an organic solvent, a lot of those processes can't happen. So the question is, do we really need them to happen for life to develop? Or are there other biochemical or chemical means?
The SLEW team has its mission while working closely with other labs involved in the project.
We all have different aspects of the problem that we're working on. Proteins are long polymers of amino acids. And what we at SLEW are doing, we're taking a look at small chemical components and figuring out how they can generate long polymers under conditions that would be relevant to a place like Titan.
There's much work to be done to determine, can life really begin in oil?
We're never going to have a tadpole jump out of a beaker after just mixing chemicals together. It just doesn't work that way. We get excited about very modest gains. Like if we could take a molecular building block like an amino acid and get 3 or 4 or 20 of them strung together, then that makes us really excited, even though most people would say, that's just one small thing of what's going on.
But the small things can lead to bigger things here on Earth.
Figuring out how life works and what life is. We don't even have a good definition of life that doesn't have problems. But maybe there's something that we're missing that's so fundamental that would be incredibly useful for biology, for biotechnology, for medicine.
And Brocker says NASA's interests go beyond this world.
If life were to develop somewhere else, what should we be looking for? And that's one of the big things that NASA wants to know.
For Innovations, I'm Kathleen Berger.